The lambda function has its roots in lambda calculus, which is a model of computation that was invented by a man named Alonzo Church in the 1930s. It's a feature of what's called functional programming, which we'll get into later on in the semester. Lambda functions are also known as anonymous functions, which I think you'll see why in the next slides. So we know about functions. We know about function definitions. There's an example right there, a def with a function name and a return statement. And here's one that we've used to pass to the argument in the sorted function as the key. So to tell the sorted function what to look at when it's sorting, when it's comparing two items, and how to sort those. This is actually how most programmers would write that same piece of code, and it would work the same. So instead of this sorting function, which was defined up here, they'll use this keyword lambda followed by a variable name, a colon, and then this right here, which is the item square bracket 1. So again, accessing the second item in that variable item. So no definition function, just this, just one line of code that gets stuck right there as the key argument. What's going on here? What is this lambda? Well, let's take a look. Now there's two ways to define a simple function. We know this way. Use the def, you have your function name, your parameters, and then a return statement. And this is a very simple function, right? It's just doing a multiplication and returning the value. The second way is with lambda. So here we have a variable square, which is assigned to this line of code, which starts out with the keyword lambda, and then some other stuff. Now pay attention here. So this is doing the same thing, and we can actually see that it has some of the same elements. These are both function definitions. So we have this x here, this variable, which is our parameter. And we've got the square, which is the variable name, and then we have this calculation, which is x times x. So in both of these definitions, we have a function name. On the left, it's the def followed by the function name. On the right, it's just like a regular variable name, actually, with an assignment operator. We also have our parameter variable, our parameter name, and we have the thing that we want to return, the calculation that we want to be done, and then evaluated and then returned. And we can call these functions, these two functions, the same way, using the square, using the function name, and passing its argument to it, and it will work exactly the same way. So these two function definitions are equivalent. Now, note, however, this only works if the function is simple, a simple one line with no code in between the function definition and the return statement. So it immediately returns some calculation. That's because you can only put a single line of code after the lambda x colon. So if your function definition requires more than one line of code in order to work correctly, then you can't use the lambda function. So here's the syntax for the lambda. And there's a couple of things to note. So first of all, you can create a function with just one variable. And you do this with the keyword lambda, the variable name, the colon, and then the expression that's going to do the calculation or whatever needs to be evaluated and then returned. And it uses the variable that you put right before the colon. You can actually also use multiple variables. So just like a regular function definition can have multiple parameters, you can pass multiple variables to the lambda syntax. And then the expression that you want to be evaluated and returned can use both of those variables. So maybe x times y. So you can use multiple variables in Lambda. You cannot use multiple lines of code. It must be a very simple function. So it's actually fairly simple. It does get confusing because you're so used to defining a function with this way that we see right here on the screen, with the def and this that 2 lines of code, the return statement and all of that, even very simple functions, it's, using all of those keyword and the 2 lines of code. The Lambda is actually simpler, but you do need to pay attention here, and it's good to walk through because it can be difficult once you're used to one way to then learn the other way and remember how the elements in one corresponds to the other. So again, note that these two are exactly the same. You can call them in the same way. They will operate in the same way. But let's just look closely one more time at how these two correspond. So first of all, we have our parameters, which are variable names. We have them here, and we have them here. They're not in parentheses, but they do go before a colon in the Lambda syntax. And then we have the expression that's going to be evaluated and returned. Here it's after the return statement, and here it's after the colon. We do have to have this Lambda. So say, for example, we don't have the def and we don't have the return, but that Lambda keyword does need to be there. So we start out our Lambda function with the keyword Lambda. And if we want to give this function a name, then we are going to give the variable an assignment operator, just like we are assigning anything to a variable. And that will work exactly the same way, give us the same results. Now, just like you can take anything and assign it to a variable, you can take a Lambda function and assign it to a variable, as we saw, assigning it to the variable add, but you don't have to. So what happens if you don't assign it to a variable? If you just write it on a line of code like this and then run that code, it's going to return this funny notation here, function underscore main underscore dot lambda x. And that's just Jupyter or Python telling us this is a function. Woohoo, we have a function, thank you. That may seem a little odd, but actually it's the same as what happens if you take any other data type, any other data, and put it on a line and run it. It's going to give you back exactly what you gave it. So that code on the previous slide is just telling you this is what you have. You have a function, and here we're running this list. Type it out and then run it. Python's going to give it back to you and say, here's what you have. You have a list. It's kind of echoing back what you gave it. So it's just going to repeat it. So it's not an error that you saw, it's that that function is a function and it's echoing that back to you. And it's perfectly fine to use a Lambda without the variable names. And that's where the name anonymous function comes from for the Lambda. And because we can create a function and never assign it a variable name, that's why they're called anonymous functions, right? So sometimes we want to pass a function to another function. It's a one-off thing, maybe, just like we might pass an integer or a float. And it's just not worth the trouble of giving the function a name. It's just we're going to use it very quickly. We want this function to call this very, very quick function. So that's a great place where you would use a Lambda. And for example, with the sorted function, we have that key argument, and we just want to very quickly give it this function, tell it what to look at, and return which element that it's supposed to sort by. And it's the same as what you're doing with lists and other data types. For example, you're going to pass a float to a function. You don't have to assign the pi value to a variable. You can just pass the number itself directly to the function. Or a list, you can pass a list directly to the function instead of the variable. So it's the same with the Lambda function. We don't have to assign this Lambda function to a variable. We can just pass it directly into the function so that the function will call it and do this very quick calculation. And it's just declared right there instead of being defined by itself in another part of the code. So let's look at 3 different ways that you can use the sorted key argument. So this is the one we saw before. So the key argument here is we've defined a sorting function, and it's taking the name of that function, which is a sorting function. And it will, at the proper time, as it is sorting, call that function. So we'll go back to the definition that's been written in a different part of the code, and it will call it. We can do that same thing with this lines of code. So again, we've created a separate function. It's not a function that's been declared right there in the sorted function. It's on a separate line. It is a Lambda function, so it's the exact same function as the sorting function up above, and we've declared this Lambda function, and then we've assigned it to a variable, which again, we're using the variable name sorting function. And just like in the previous code snippet up here, we can just pass the function name to the key argument, and it will work the same way. When it comes to the time where it needs to figure out what to look at, it will run this Lambda function, which will return the second element. Or we could save ourselves another line of code and just take that very short Lambda function and pass it directly to the key argument. So we're passing this function, the function itself, not the function name, but we're passing this function itself as an argument to sort it. And it will work exactly the same way. With that Lambda keyword, Python will know that this is the function and run, here's my variable, and here's the thing that I need to evaluate and return the value of.